We are going to proceed with Thevenin theorems. This is one of the examples. Find the Thevenin equivalent circuit at terminal AB. So this is terminal A and this is terminal B. So to solve this question, we must always remember this principle. What is the principle? We must always remember at the end of our analysis, we want to identify equivalent circuit of the Thevenin that comprises of VTH in series with RTH, and you need to connect it to the terminal. So in this case, we have A, we have B, so we have A here, we have B here, and this is our VTH. So let's continue with our procedures. So we have actually 4 procedures, 1, 2, 3, and 4. Okay. The first one, we need to remove any load from its terminal. Okay. This is our original circuit. This is our terminal A as well as B. Okay. What we need to do, step 1, we need to remove. So we already remove our RL. So no more RL here. So this is our first step. Step 2, once we remove our load here, so this is our step 2. In step 2, we need to calculate here, okay, our RTH with all independent sources are being turned off. Now, let's check. From our first step, this is our independent sources. This is our independent sources. So over here should be in this way. We already short circuit our voltage source. Okay. And here is actually our original 5 ampere. So we put it on the open circuit. So from this terminal, we can calculate our RTH. So we have, since we already opened this one, so no more current flowing through here. So we have 4 ohm, 6 ohm, and 2 ohm in series. Altogether, we have RTH equal to 12 ohm. Now, we are going to continue with step 3, whereby we need to calculate our VTH over this terminal. So we can have various options. For example, we can use nodal, or we can also use mesh. So it depends on the complexity of your circuit. For example, we have Vx over here, okay, for us to be. So if you are using nodal analysis over here, Vx minus 20, okay, divided by 4 plus 6. This is why over here is 10, 4 plus 6. Okay, and this is actually your 5 ampere plus 5 ampere. So easily you can obtain Vx equal to 70 volt. Finally, as we discussed earlier, our target is to obtain our equivalent circuit. So you must remember, if you are dealing with Thevenin, series with your RTH. Okay, so this is your VTH, this is your RTH in series. Then you reconnect your loading over here. Finally, this is your RTH plus VTH, which is actually your equivalent Thevenin circuit. Thank you.